In this video, we are going to go over both section 5.4 and 5.5. Now, 5.4 covers the definite integral, and 5.5 covers the fundamental theorem of calculus. Earlier in chapter 5, we learned how to take the integral, antiderivative. We just take the antiderivative, we get a function out with the constant term plus c. Now, what's different in chapter 5.4 and 5.5? Now we are going to take a step further and evaluate with the given value. So if you recall what we did in derivative, we were able to take the derivative and we could also use the number to plug it in and get a single value. So same concept. Not only we take the antiderivative, now we are going to actually look at interval where we are going to antiderivative and then apply those number into the function and get a value out. So here's the concept. So I pull out a PowerPoint and let's say we were given this function f of x as 0.25x squared plus 1. That's parabola, so you see a curve. And the question is, how can we find the area of shaded region in the figure? And we are only considering certain region of our function. So the boundary of the regions are vertical line starting with 1 to 5. So that's the interval that we are interested to calculate the area. And one way that we can do is, and use a little bit of a geometry, break a little bit into a rectangle, small pieces of rectangle, right? So you divide this region equally into 4 rectangles, and then create a rectangle, and then start adding up R1, R2, region 3, and region 4, and then get the value because we know how to calculate the area of a rectangle. So we sum it up one way using the 4 rectangle. Here's my length. That's a 1. You know, how do you know that this is 1? Well, you know that between 1 to 5, we are dividing exactly into, right? So we have, let me erase this. This is a region of length 4, because 1, 2, 3, 4, and then divided into 4, we get a length of 1. So that's what that 1 is, the length. And then height, of course, will be f of 1. This will be your f of 1, the height. This will be your f of 2, height. F of 3, and then f of 4. So you get a rectangle. Now, notice that we use this left point, left side. So we approximated area with the left sum. So that's what that L4 is. And if you actually use left sum, you are underestimating area. Then you should get less than the actual area. Why? You technically have this area that we didn't add it up. So we are having an underestimation. Now, you can also do the opposite. Create 4 rectangle, but instead of left point, use the right as a height. Then you are actually overestimating, right? We divided exactly into same length of 1, but instead of left point, now I'm using the right. Then I'm actually creating a right sum, so r sub 4, and then this right sum will be actually greater than my actual curve because I have this extra pieces sticking out. So we have this approximation going on where you can approximate either left or right. If you use the left sum, you're underestimating. And then if you're using the right sum, then you are overestimating. So that's the concept that we are going to take. Now, if you divide more rectangle, you're gonna get more accurate, right? Take a look at the next slide. This one, instead of 4, I'm dividing into 8. Then you're gonna have a smaller pieces, add them up, and then you're going to get a better approximation. So that's the concept, and this process is called Riemann sum. Okay, so it's called a Riemann sum. So now I'm going to pull out our notes and then go over the two theorems that we just went over. The limits of left-right sum. So if we start creating a rectangle using left and right and create bunch of rectangles, bigger, and eventually if you go that to the infinity, small, as many as possible, you're gonna get a whole area underneath the curve. So that's the one concept, limit of the left and right hand sum. We saw that 4 rectangles versus 8 rectangles, better approximation. So if I start adding more for my n, so 10 rectangle, 100, 1,000, then as n goes to infinity, you're gonna get a better approximation. So that process of taking to the infinity, that's called limit of Riemann sum. If f is a continuous on function a to b, then Riemann sum on the interval a to b approaches a real number, limit L, as n approaches to infinity. You're gonna get certain number as n approaches to infinity. Definition, definite integral. Let f be the continuous function a to b. The limit of I of Riemann sum is called a definite integral of the form a to b, denoted as a to b, antiderivative of a to b of f of x dx. So this a and b is those interval. From the PowerPoint, it will be 1 to 5. So this is general property. So earlier in chapter 5, remember these, we didn't have these numbers. It was just integral f of x dx. Now we are just adding these number from 1 to 5, 2 to 3, right? Looking at certain part of the region. So that's what makes it different, definite integral. Now, if you're just evaluating from a to a, think about this, just 1 to 1. I don't have any area, so this will be a 0. Now, if you evaluate a to b of f of x, that will give you the same thing as the opposite of now you are limits, lower limits, and upper limits. You can flip that as long as you make a negative, and it will give you equality. Same thing from last property. You can pull out the k out of the integral, so constant comes out, and it's not going to change anything. When you are summing up, you can separate the integral. And then you can also, instead of looking at, so recall on the, let's say you have something like this, right? Then you can also divide 1 to 3, integrate, and then 4 to 5. That's what this means. You can divide up the regions from instead of looking at the whole chunk, break it into pieces. That's what the last property is. So we are going to be beginning with these two concepts, the Riemann sum for the first two problems. So actually calculate the area of left triangle and then left rectangle and right rectangle, and eventually use the property to solve the problem. Okay, so let's go to the first problem. Problem 1 and 2, calculate, indicate Riemann sum. So that's what S of n is, sum of a function 7 plus x squared. So we will use the same function. First one, partition from 1 to 9 into 5 sub-intervals into equal length for each sub-interval. Let c sub k be the x of k minus 1 plus x of k divided by 2. All right, so this number right over here will be this x of k minus 1, look at the interval. So we have a closed interval. The first number will represent x of k minus 1, and then this x of k will represent 9. And then we are going to be dividing into 5 sub-interval. That means 5 rectangle. Okay, so let's begin calculating some c sub k, okay, and that will be your height of a rectangle. So if you recall what the x squared plus 7 on the interval -1 to 9, and you can use calculator. I'll show it to you. So we have 7 plus x squared, and then let's say we are only focusing on -1 to 9. So we are looking at this curve here, this curve only, and then finding the area underneath the curve. So this was what was happening, right? Something like this, all the way up to 9, and considering these areas. All right, so what is my length of rectangle? Well, I'm going to be, so that will be my delta x. So that's the label for the length. I'll write it up, length of rectangle. So I'm going to add those two numbers divided by 5, because I want to divide it into equal 5 pieces, right? So 9 minus -1, and then so finding the length, so that will be 10 over 5, which is equal to 2. So each length, 1, 2, 3, 4, 5. Let me use a different color. Right? This will be equal to 2, right? 2, 4, 6, 8, 10. So length of 10. Now, what about C sub 1, right? C sub 1 will be your points that used to put it into the F, so we get the height. So let's begin with C sub 1 all the way up to C sub 5, because there are 5 rectangles. So C sub 1 is calculated as, we have the first one. If this is negative, oh, my drawing is a little bit off. Let me do a better job so it's more accurate. So -1, so it will be length of 2, so 1, 2, so it will be 1, right? The rectangle. And then 1, 2, so it will be 3. Next one, 5, 7, and 9, right? Something like this. Right, so this one, so we have a 5 rectangle. So C sub 1 is calculated as, so this is your upper interval and then lower interval, so that's your x of k minus 1, and this is x of k. So your C sub 1, the first one, will be -1 plus 1 divided by 2. Okay, now technically you can do 1 plus -1 as well. Addition is commutative, so you can either add -1 plus 1 or 1 plus -1. It will give you same, so this will be equal to 0 over 2, 0. C sub 2. What is C sub 2? Now I'm looking at 1 and 3. So 1 plus 3 divided by 2, you will get 2. Let's do C sub 3. C sub 3 will be now looking at 3 to 5. So 3 plus 5 over 2, which is equal to 4. Okay. And then we have C sub 4. Which will be equal to 5 and 7, right? 5 plus 7 divided by 2. So that will be 12 divided by 2, 6. And then last one, 7 to 9. So C sub 5 will equal to 7 plus 9 divided by 2, which is equal to 8. Now, to calculate sum of 5, your Riemann sum, that's what this, let me pull out the PowerPoint really fast. Okay, so these will be your C's. This will be C sub 1, C sub 2, C sub 3, C sub 4. So we are going to plug that into our function, and that will be your height. So let's do that. So I should have, the format looks like this. F of C sub 1 times your height will be 2. Length, I'm sorry. This will be your height, the length will be 2, so 2. F of C sub 2 will times 2, always the length of a rectangle is 2. And then F of C sub 3 times 2, F of C sub 4 times 2, and then F of C sub 5 times 2, and let's keep going. Well, if I take 0 and plug it into this, F of 0, that's 7 plus 0 square, which is equal to 7. F of 2 is 7 plus 2 square, which is 7 plus 4, which is equal to 11. F of 4 is 7 plus 4 square, so that will be 23. And so on. F of 6 will be 7 plus 6 square, which is equal to 43. And lastly, we have F of 8 is equal to 7 plus 6 square, which is equal to 71. Okay. And then we are going to be substituting. So this part over here is a 7, so that's a 7 times 2. This will be 11 times 2, 23 times 2. And then we have 43 times 2. And then 71 times 2. Let's do some math. 7 times 2 is a 14. Plus 11 times 2, 22. Plus 46. Plus 86. Plus 142. So your sum of 5 is equal to 310. Okay? So 310. Let me pause for a minute and see if we are okay here. Now, number 2 is exactly the same. We will be using the same function, but partitioning from -4 to 8. So your curve starts at -4 all the way up to 8, so it will be kind of like more lower like this. And then you're partitioning into 4 subinterval. So you're calculating at sub 4. Okay, using the same rule, okay, same rule, I'm going to leave this one out for you. I'll still write down the format though. F of C1 times delta x, whatever the delta x is, F of C sub 2 times delta x. Delta x is your length of a rectangle, so it's consistent because we are dividing into equal pieces. F of C sub 3, delta x, f of c sub 4 times delta x. You do that each time. Calculate c1, c2, c3, c4 delta x. Multiply, sum that up. You should have s sub 4 as 246. Okay, so please try number 2 on your own and then check to see if you get 246. So that's the first part right over here, the Riemann sum. We use the Riemann sum to get rectangles and then add them up to approximate the area under the curve. Now remaining one, we are going to apply the properties to calculate the definite integral. So let's take a look at 3, 4. I will do 3 and 4, and then you're going to be doing 5 and 6. So I just cross it out for you to try because it's very similar to 3 and 4. And then we'll do number 7 together. So 3, 4, 7, we'll do it together. In problem 3 to 7, calculate the definite integral, and we are given these conditions. From 0 to 6 of x of dx, that area is 18, so they did the calculation for you. We are going to be using these, what we are given, modify our equation, and then substitute those values. Okay. The second one, they give you from 0 to 6, x squared function is equal to 72. They did some math and then did all those rectangles and then take the infinity. And 6 to 9, x squared dx is equal to 171. All right, let's take a look at number 3. Now, number 3, if you look at it, take a look at first. You have 0 to 4, right? Your integral begins at 0 and stops at 4. None of them has a 0 to 4. Follow that? So what we have to do is we have to use these properties to rewrite, and thankfully we have these last property where we can separate, right? I erased it, but remember I did the 1 to 5, and then first one I did 1 to 3 and then 4 to 5 and sum that up. That's how I'm going to modify so that I'm only looking at 0 to 4. I also noticed that we have a 3 in front, constant, so it's possible that I'm going to use 3, move the 3 out. So it looks like I'm going to be using 2 properties. These are the things that you want to look for. What are some properties? What do I have? So how can I use the properties to modify? So let's do that. First, using property number 3, I pull out the 3 outside. So 3 outside of the integral 0 to 4, and then x dx. Okay. I'm sorry, there's a typo on my notes. Sorry for the typo. Let me fix the typos. These are supposed to be going all the way up to 6. Here. And then this one also 6. And then, let me see, this is 0 to 9. And then 0 to 6, this is fine. And then 7 to 7. Okay, so 5, sorry for the typo, 3, 4, 5, you have those ending upper limit typos, so fix that. Okay, so actually we are not going to be using number 5 because we are given 0 to 6. Okay, we cannot separate those interval of what's given. Those are already given, so we cannot deal with modifying this. Okay, so 0 to 6. So this will be easy. This part right over here is actually given right there. So do the substitution. This really means 3 times 18. So number 3 will be 54. That's it. Now, number 4. We have the addition, so why don't we separate addition by using property number 4? So I can do this, 0 to 6, 2x dx, and then 0 to 6 x squared dx. The number carries over. You see that a to b, a to b, a to b. Even though you separate it, the number stays consistent. Also, notice that 2 can be pulled out just like the number 3. I'm going to do that. 2 pulled out constant term, 0 to 6 x dx. And then 0 to 6 x squared dx. And notice that over here, the x squared dx from 0 to 0 to 6 is right there. And then I also have the x function, 0 to 6. So I do the simple substitution, 2 times 18 plus 72. So my final answer will be 36 plus 72. So my whole integral from 0 to 6 of 2x plus x squared dx will be 108. Okay, very simple. Next section, we are going to actually learn how to calculate this number instead of doing a rectangle. And that's what the fundamental theorem of calculus is. So I'll leave 5 and 6 for you to try. Okay, and then I will still give you the answer. The answer for this I have is 486, so you can check. And number 6 will be negative 126. Okay. Notice that I have a hint. This is 0 to 6. This is 0. 6 is on the bottom and then 0. That's different. So you have to use property number 2 where there's a negative introduced. So your answer will be a negative value. So that's why you see the negative. So hint, use property number 2 so that there's a negative. Number 7, I'm also going to use the property. This one doesn't matter. I don't even have to separate. I don't have to do any of the math. If I recognize that it's from same number, the lower limit, upper limit, I can just use property. We are given this. Any function from same number, a to a is a 0. So same thing. Doesn't matter what this function is. It's 7 to 7, 0. Okay. So that's a quick and very short and quick section. Let's move on to right away into 5.5. And it's very connecting. Now you're going to actually learn how to calculate this. So how do they get from 6 to 9x squared dx as 171? Fundamental theorem of calculus says it's basically taking the antiderivative of the function f, so that will be your capital F of x, and then substitute this b upper limit, and then substitute the lower limit, and then subtract. It's kind of similar to subtracting the overestimate and the underestimate of a rectangle. Then you get kind of like cancellation. So that's where that subtraction comes in. Another one, average value of continuous function. You see the word average, so you see that 1 over b minus a. So that's added on in front of our antiderivative. Whenever they say find the average value, you just add that 1 over b minus a. So let's try a couple practice problem, and then I will also circle the problems for you to try, but I will give you the answer. Number 1. We're integrating from 2 to 6. So there's your a and b. So a will be 2, b will be 6, and your f of x is 8x cubed plus 3. Now, recall, don't get too caught up with 2 and 6. Just ignore that for a minute. Okay? And then let's integrate it. In 5.1, 5.2, we learn how to integrate, for example, 8x cubed plus 3, right? You know how to do this one if I give you this. So we add 1 power divided by new power. So my first term will be 8x to the 4th divided by 4. And then the constant will be 3x. Now we are done with the integrating, and we are not going to put plus c because we have a number now to plug it in. So this is the way we notate it. Vertical bar and then 2 and 6. That means I am done with taking the integrating, but I need to evaluate these two values. So fundamental theorem of calculus says, literally, that's what it is. Your antiderivative of a function ended up being 8x to the 4th over 4 plus 3x, which reduced really down to 2x to the 4th plus 3x. So let's even write that, 2x to the 4th plus 3x. And that's what this means. F of 6 minus f of 2. That means f of 6 is 2 to the x to the 2 times 6 to the 4th plus 3 times 6, which equals to 2610. And then f of 2, you can all do this by separately. Plug it in, 2 here. So 2 times 2 to the 4th plus 3 times 2, which equals to 38. What are we going to do with these two numbers? Subtract. And you will get the final answer will be 2572. So that's what the area is. We now are going to just use the theorem to get the area rather than drawing bunch of rectangle. Okay, that's what the fundamental theorem is. You're done with creating the rectangle. I'll give you the formula. I'll give you the theorem. Just use the theorem to solve, which is very efficient. I don't have to calculate the length and height, and then multiply, sum that up. I can just evaluate it, plug it in a number, and subtract those two upper limit and then lower limit value. All right, so let's do a bunch of practice. I will do this whole page with, I will do 2, 3, 4, the whole thing with you. I'm gonna leave 5 and 6 for you to try. Okay, so 5 and 6 is for your own exercise. And then I will do 2, 3, 4, 7. Okay. All right, so moving on, number 2. Okay, so same thing. Simple one. 2 gets pulled out, and then e to the x, antiderivative is e to the x. So the antiderivative function is 2 times e to the x. We need to go 0 to 5. So that means by the fundamental theorem, this will be f of 5 minus f of 0. You can do on the side, or I'm just going to put directly over here to save space. So this will be 2e raised to the 5th power minus 2e raised to the 0 power, right? This first part right over here. The second part will be right over here. Okay, and then what do we do? Well, this is 2e to the 5. Anything to the 0 power is 1 minus 2. You can leave it like this, or you can use a calculator. My math lab might ask you to round it to the certain decimal place or leave it out as an e term. I'll just round it to the 2 decimal place. If you get a decimal number, this will be 294.83. Okay. Number 3. Oh, this over here, you see, you can do a shortcut. If you recognize that it's 7 to 7 by the theorem, this will be just 0. Okay, so I'll make a note. Since the upper limit and lower limit of integration are the same value, we get a whole thing equal to 0. One more together. I don't like this root. I'm going to rewrite it to a more friendly function to integrate. And you can do this by putting x plus 3, raise it to negative 1/2 dx. Okay. Then 5 gets pulled out. This one over here, you're going to have add 1 divided by the new power, right? So and then you can do the u substitution. You see, kind of change. Something raise it to the power. So x plus 3. This will be du, will be just dx. So this one, u substitution, you learned it last week. 5, 12, 13. Technically speaking, now I changed the value, changed the letter to u. So these are not 13 and 22. So leave it as a question mark. You're gonna have, and then I'm gonna resubstitute back when we have an x function. So you have this u, raise it to the negative 1/2 du. So 5 u negative half plus 1 will be just half. So raise it half divided by half. Still question mark because I have u. I'm gonna substitute back 13 and 12 when I have a x back. So this one over here with the bottom and this will make a 10u to the 1/2. Substituting back 10, u really is x plus 3/2. Now I can rewrite 13 and 22 because now I have a x. So this means by the fundamental theorem of calculus, we can just take f of 22 minus f of 13. Let me make this one a little bit small so I have a little bit more space. Okay. Right, now f of 22, here's my function, right? So f of 22 minus f of 13. So 10 times 22 plus 3, raise it to the half. 10 times 13 plus 3, half. We're going to do some math. So this will be 10 times, that's 22 plus 3 is 25. Square root, that will be 5. And then this is 16, so square root will be 4. So the final answer we get 50 minus 40, which is equal to 10. The area will be 10. Five and 6, I will leave it for you. For both problem, you need use substitutions. Okay, use substitution. So my hint is use substitution, just like we did it in number 4. And number 5, the answer ended up being, and then I just rounded to the two decimal place, 1857.07. And then number 6 will be 1.70. Okay, so try these two problems on your own. But I will do number 7 with you guys. Number 7. Again, I see that square root. So I'm going to do the u substitution. So let's begin with the u substitution and then integrate. U will be 6x squared minus 1 because I see kind of chain rule. Inside function as u. My du will be 12x dx. Remember the trick that we saw? I have only 3 and then I need 12, which means you can rewrite this really as a 4 times 3x dx. 12x is same thing as 4 times 3x. So I already have this one, that's this x dx. So I need 4 to be multiplied. So I need to multiply outside by 1/4 to cancel that out. So my function look like 1/4. And then I will leave out as a question mark because 1 and 2 is really for the x. I'm going to have a square root of u, now du, with the 4 times 3x and then dx. Which is equal to 1/4. U raise it to the half du. Half add 1, that will be 3/2. And then we raise by that and divide by that. So I'm going to have 1/4. U raise it to the 3/2 divided by 3/2. Notice that integral disappear because I already took the integrals. 1/3 and then 1/4. If I divide that, that's going to be 1/6. U raise it to the 3/2. And let's do the back substitute of the u. U was 6x squared minus 1. So 1/6, 6x squared minus 1, 3/2. Now these number I can resubstitute as a 1 or 2 because now I'm dealing with the x. This whole part is your capital F of x. So now it's the evaluation part. F of 2 minus F of 1. F of 2 minus F of 1. So that will be 1/6. 6 times 2 squared minus 1, 3/2. 1/6. 6, 1 squared minus 1, 3/2. So let's do some math. Do a little bit of simplifying. I'm going to have 1/6. Inside I have, I'll actually do the whole math here. So if I simplify this, the first expression ended up being 125/6. This whole thing, that's a 6 minus 1, 5, raise it to the 3/2, and then divide by 6. I'm going to get square root of 343 divided by 6. You can leave it like this, or in decimal, rounding to the 2 decimal place, I got 17.75. All right. All right, let's take a look at now average value. So average value, we are given this extra piece. We have to have 1/b minus a in front of the integral. So number 8, I will do it. Number 9, you get to practice. So I'll still give you the answer for number 9. But I'll give you, we'll do number 8 together. So since we are finding the average value, I'm going to be writing this. Rewriting 1/b minus a. My a and b is 1 and 6, right? So, but the formula says f of x dx. So let's do some substitution. So this will be 1/6 minus 1. Integrate from 1 to 6. And then you have 8x cubed minus 16x plus 4 dx. 1/6 minus 1, that is 1/5. This is a very easy one to integrate. Term by term, raise power, so 4 divided by 4. So that will be, the first term will be 2x to the 4th. 16x squared divided by 2, negative 8x squared plus 4x. I am done integrating, so I put 1 and 6. Okay, now same thing. All we have to do is 1/5 stays out. This whole part is really f of 6 minus f of 1. So that's the only difference. You just have that 1/b minus a when you're taking the average value. So 1/5, the first part will be 2, 6 to the 4th minus 8, 6 to the square. plus 4 times 6. So that will be your f of 6 minus f of 1. 2 times 1 to the 4th minus 8, 1 squared plus 4 times 1. And then 1 over 5. This part over here is 2,328. This is, if you simplify, I got negative 2. Negative with the negative makes positive. Divide by 5. Final answer, I'm getting 466. Okay. So average, as you if you see the average value, add this. No, add this in front of the integral. Okay. Number 9 works exactly the same, but hint will be when you are integrating, you need to use substitution, because there's that negative 0.3x. So very obvious that you're going to put negative 0.3x as a u. But you do the same thing. It's not a bad one to integrate. At the end, your average value will end up being, so here's the setup, b minus a, antiderivative, a over b, and then this will be your g of x dx. So you end up having 0.63. Okay. All right. The last two problem is dealing with application problems. So I want to go over those two. Make sure that you have some application problems to look at when you are working on the homework. So let's go over both 10 and 11. Number 10. The total cost in dollars of manufacturing X unit of a product. So we are making something, and then the total cost will be 50,000 plus 400X. Find the average cost per unit if 400 units are produced. Hint, recall that C bar, that's an average notation. So that's what we are finding, C bar. And this one, you can recall, these are all coming from chapter 2.7. So a little bit earlier into the semester, we learned how to find average cost, marginal cost, and so on. B, average value. So you see the average value. So you're going to have some kind of B minus A going on. Okay? So as soon as you see the average value, that's what you're going to do, 1 over B minus A. So let's first begin with A. A, we need to calculate C bar. My X will be 400, right? C bar X. Now recall the C bar X from chapter 2.7, the formula is cost function divided by X. That was how we calculate the average. Cost function whole thing divided by X. What's my cost function? 50,000 plus 400X divided by X. So I'm going to separate it and rewrite 50,000 over X plus 400. But we are finding X as a 400, so let's substitute it to 400 for X. So that will be 50,000 divided by 400 plus 400. So I'm getting first one, 125 plus 400, 525. That's it. Very simple. Part A, we're done. So therefore, what does 525 mean? The average cost for 400 units is 525 per unit. Okay, little bit of a review of chapter 2. Part B, find the average value of the cost. Now, they just want the cost function over the interval 0 to 400. So that's what we are doing. 1 over b. I'm going to actually copy this one because this is our formula. Your b is 400, your a is 0. So I'm going from 0 to 400. Oops. 400 minus 0. 0 to 400, your f function will be your cost function. Not the average cost, just the cost function. So this will be 50,000 plus 400x dx. Very easy one to integrate, so let's do that. 400 divided minus 0 will be just 1 over 400. And term by term, I'm going to have 50,000. That's a constant, so we get a x. 400x squared divided by 2, so I'm having 200x squared going from 0 to 400. And we are going to multiply that by 1 over 400. There's my capital F of x. So by the fundamental theorem of calculus, I just have to calculate 400 minus capital F of 0. 1 over 400. So this first part right over here will be 50,000, 400 plus 200, 400 square. Subtract 0, 0, right? Easy one. So I'm subtracting really the 0. So little bit doing some algebra. Let's simplify this. If you do that, I'm getting 52 million divided by 400. I get 130,000 as a final answer. So this means the average value for the cost will be 130,000. And out of space, so I'll just write it over here. Therefore, the average value of the cost will be 130,000. Okay? Let's do one more, and this will be the last application problem, number 11. A company manufactures a product and the research department produced the marginal cost function as C prime of x as a 300 minus x over 4, where x is between 0 to 800. Where C prime is in dollars and x is the number of units produced per month. Compute the increase in cost going from a production level of 400 to 800. So we consider 0 to 800, but now 400 to 800 unit. Set up the definite integral and then evaluate. All right, so let's do that. This is what we want to do. Compute from 400 to 800 of our production level, right? So instead of 0 to 800, we want 400 to 800 of our C of prime x dx. So let's set up. That means that's 400 to 800 of 300 minus x over 4, because that's our cost function. Marginal cost function, and then dx. All right. Now let's evaluate it. So we got the setup. All we have to do, take the integral and then use our fundamental theorem of calculus, evaluate and subtract the two value. Very easy one to integrate. So if I integrate term by term, that's a 300, which is a constant, so 300x. And then you have a x squared divided by 2, so x squared over 8, going from 400 to 800. So that's your capital F. So F of 800 minus F of 400. So let's do that. I'll use a color code. So first one, 300 times 800 minus 800 squared over 8. Subtract, let's do green. The 400 will be 300 times 400 minus 400 squared divided by 8. And all I have to do is just simplify. This first part, doing some math, simplifies to 160,000. And then the second part, if you do the math using the calculator, it simplifies to 100,000. So the difference will be of 400 to 800 c prime of x dx. We get 60,000. Done. So just writing a sentence. Therefore, the increase in cost going from 400 units per month to 800 units per month is 60,000. All right, this is the end of antiderivative, and on the next video we will begin chapter 6.